Good morning and welcome. Wonderful day today in Bangalore. And so to the wonderful talk by Rajesh, I really feel good about it, actually. We'll go forward. Approximately, I just wanted to recall what the child did at the age of 2. Approximately 8 years ago, on 29th of December, the foundation stone of the ICTS campus was laid by Professor C.N.R. Rao in the presence of David Gross and Michael Atiyah. To mark this event, we organized a 5-day meeting called Science Without Boundaries. The program of that event consisted of keynote lectures in traditional areas of the basic sciences, as well as interdisciplinary areas, and including 2 panel discussions to guide us about the importance and viability of what is called interdisciplinary research. There were also several public lectures by eminent scientists, David Gross, Avi Vigdason, and Albert Lipscheber, as part of the ICTS outreach effort. This meeting was organized to put forward our intentions about our mission, our intentions, what we plan to do. And I'm very delighted to say, actually, that this meeting that begins today will confirm, because I know what's going to happen in this meeting, that we have gone some way in fulfilling our mission. Our mission, our ship sails on. The captains have changed, but the ship goes on to its destination. And with these few words, I'd like to welcome David Gross to deliver his inaugural lecture. Well, needless to say, the speaker needs no introduction. And besides his immense contributions to physics, he has made an enormous contribution to the ICTS from its very inception, which I will be very happy to detail tomorrow during the after-dinner speech. So with those few words, I welcome you again and welcome David to deliver his talk. David.
Thank you. It was awfully loud. Thank you, Spenta. Thank you, Rajesh. And welcome, everyone. It really is a great pleasure to be here at the 10th anniversary of ICTS. For me, ICTS has been a dream, now a reality for more than 15 years. And it is always a pleasure to come back and to see that dream turn into reality. Let's see, I think this picture was taken 5 years ago. And Spenta and I were out with the construction company looking over, and on my face shows a bit of skepticism that this field would turn into the dream. However, when I woke up this morning, after arriving after midnight last night, and looked out, I could see that it actually looks like the dream. And certainly the scientific achievements, the programs, have fulfilled, I think, our wildest expectations, and will continue to do so. Now, this next few days are devoted to science, the unity of science across the many fields that are represented at the ICTS. Most of the speakers are going to talk about their exciting results, their research at the frontiers of the many fields of basic science. But I'm not. At this occasion, I have not going to talk about the SYK model that I've been working on recently. I did that last year, and there will be 6 hours from me and my collaborator next week at the school on the SYK model. Instead, I thought I would talk about truth. I had the occasion last month during the Nobel Prize ceremonies to participate in the Nobel Week Dialogue, which is held the day before the Nobel Prize ceremonies. And this year, it was devoted to the very timely subject of truth, and in particular, the concerns that we all have about the future of truth. And I was asked to talk about truth and science. This was a very interesting symposium. Much of it is available online on YouTube. It featured talks from people who know actually what's going on in Washington, like the ex-director of the CIA and one of the New York Times correspondent, White House correspondent, and so on. But there were also presentations from scientists, and I delivered the opening address on truth and the scientific method. So that's what I'm going to talk about in a brief talk this morning. Now, when I started to prepare this talk on truth, the question immediately came up, what is truth? Well, if you look at the dictionary, you find it's kind of surprising. Truth is defined tautologically. Truth is the quality or state of being true. Or true, the OED, the Oxford English Dictionary, says truth is that which is true, or in accordance with fact or reality. In philosophy, this is known as the correspondence theory. Truth is what is true, or what is real, factual. Of course, totally avoids the question. Philosophers then discuss all sorts of properties of what it means to be true, such as you can't have a proposition that is both true and false. And there's a lot of mathematical discussion of logic and truth, but they never actually tell you what is true, what is truth, or how to find it. Cambridge Dictionary says the same. Truth is agreeing with fact, not false. So I propose a different definition of what is truth. The best we have. Truth is what is revealed by the scientific method. That, of course, is not as absolute or perhaps as strong a definition as you might want colloquially, but I think it's the best we have, and it's the most useful. But then, of course, like the other definitions, I need to discuss what do I mean by the scientific method. So the scientific method I regard as the greatest invention of Homo sapiens. It always existed to some extent in a very primitive form from the beginning. Homo sapiens are notoriously curious and engaged in finding out more and more about the real world and how to control it. But roughly 400 years ago, it became a well-defined method which rests on the assumption that the world of observable phenomena is real and intelligible and subject to the requirements of logic and consistency, and based on observation and experimentation. The scientific method really consists of three components: observation, experiment, and theory. Observation often asks the question, what? And explores with ever-increasing instruments the real world that we perceive directly and indirectly. But the scientific method then proceeds to experimentation, where we perform quantitative experiments on phenomena in the real world and try to understand how the phenomena in the real world are connected and how they work, which feeds directly into theoretical attempts to model and explain, and then ask the question, why? Theory and experiment are closely related. Theory makes predictions, explanations that can then be tested experimentally, and those tests are crucial to the definition of the truths that emerge from the scientific method. And finally, experiment and theory, our understanding and explanation, lead to our ability to control and apply our understanding of the real world. And this, of course, is the feature of the outcome of the scientific method that enables it to get the resources necessary to keep the effort going, since it can benefit society, which will continue to support science. But more importantly, from the point of view of science, these new applications, new controls, new instruments, new technology feed back into ever improving our ability to observe and to carry out experiments with higher and higher precision. This scientific method is continually evolving. This perhaps is the basic structure, but it gets better and better over time. For example, the use of statistics and the understanding of statistical analysis to analyze complicated data is still evolving. And we continue to develop new techniques to perfect the scientific method. But it's very powerful. And what it produces is science, which is the best candidate for truth. Now, science, as I said, is based on observation, experimentation, theoretical constructs. Its findings, the results of the method, facts and theories, are continually subject to the requirements of logic, consistency, of course, and reproducibility. But one of the features of the truth that science reveals, the science that science reveals, is that it is always tentative and always subject and must subject its tenets to experimental tests. Nature is the only judge of the truth revealed by the scientific method. But it's not a judge in the sense of, legal courts. There, a judge will say that, will decide a case and say, this is right and this is wrong. Nature, as approached by the scientific method, can only say, this is wrong. We are never definitely right. We can only be sure that we are wrong, to quote Richard Feynman. So, especially for theorists, and this, after all, is the International Center for Theoretical Sciences, we continually subject our ideas to the judge, and the judge at best says, well, you're not wrong so far. It's a bit frustrating sometimes, but it has turned out to be an extremely fruitful approach. I do admit, however, that as theorists, we often know or feel that something is right, even though nature never tells you that, because it works. And science definitely works. So again, the scientific method is based on the thesis that the final authority to scientific truth is observation and experiment. No theory or mathematical argument, no matter how compelling and beautiful, can be maintained in the face of contradiction with observation or experiment. This, of course, differentiates scientific truth from other competitors in many ways. Let me discuss some of the features of the truth that is revealed by the scientific method. One, it is liberated from its creators. Newton formulated laws of motion. We sometimes refer to them as Newton's laws of motion, but they're not Newton's laws. They're everyone's laws. They're nature's tentative laws. It belongs to no one and to everyone. Unlike other truths which apply to sects and nations and cults, scientific truth is universal. It applies everywhere and to everyone. Need not have been the case. It's a great discovery of mankind that there are these truths that is revealed by the scientific method that applies everywhere and to everyone. If you think about it, it could be otherwise, but it isn't. Science lacks all authority except for nature. That's certainly not the case in the many other competitors for other kinds of truth. And all are equal in its pursuit. There are no special priests of science or authorities. Everyone is equal. And finally, science is always bathed in ignorance. Its truths are tentative, subject to change, and continually being tested. These features of science and the truths revealed by the scientific method really are unique, are quite different from other truths. And for that reason, science and the scientific method really need an open and transparent society where all can participate and none are special to flourish. And it is an historical fact that in societies that are less open and less transparent and more authoritarian, science is not as successful. For that reason, science and the scientific method are at the heart of the Enlightenment and at the establishment of democracy. Now, the scientific method has flourished for 400 years, and it has enormous strengths. Phil Anderson once said that science is a multiply connected web which is true. All the different areas of science are highly connected to each other. There are no domains that are separate. That is a feature that is a source of enormous stability and strength. I would also add that reductionism, which is at the heart of some of us, is research, strengthens this web. The fact that reductionism works, that our understanding of the microscopic foundations of physics are at the heart, in a reductionist sense, of all of science and all observable phenomena, greatly strengthens this web. Now, of course, reductionism is not, does not mean that one tries to explain the functioning of the brain in terms of the standard model. But the fact that this all highly connected in a reductionist sense gives enormous strength to this web of truth. For that reason, one cannot argue that the CO2 emissions do not cause global warming without contradicting the truths revealed by physical chemistry, and thus the truth of the quantum theory of atoms, and thus the whole web of fundamental physics. Scientific truth is solid because of this interconnectivity and reductionism, even if it's not always convenient. Now, to be fair, there are limitations to science. Science has limitations, as there are questions that one can ask, that we all ask, that I ask, that currently, at least, cannot be addressed by observation, experiment, or theory. For example, questions like, why is there something rather than nothing? Or what is the meaning of life? These are questions that humans have been asking forever, continue to ask, and are not, at the moment at least, addressable by the scientific method. Yet they are questions that humans ask. There are other questions that were thought to be outside the domain of science, such as, what is life? What is the history of the universe? These are now part of science and addressable by the scientific method. And we're now in a situation where physical cosmology seeks to address the question, how did the universe come into being? Previously left all of these questions were, until very recently, left to religion and philosophy. Science is a bit under attack in many parts of the world, including the United States recently. And the challenges are real and scary. The search for truth can be full of pitfalls. Scientists are fallible people. They're susceptible to bias, conscious and unconscious. And the scientific method has gone to great lengths and continues to develop new techniques to police the collective scientific effort, to make cheating difficult, and to protect ourselves from unconscious bias. We're continually trying to perfect these methods, perfect our instruments, and improve our tools of analyzing data and testing our theories. Scientists aware of these dangers correctly admit to uncertainty and are generally careful and cautious in their conclusions and predictions. This can produce confusion outside of science, where such restraint is uncommon, even as the basis for pronouncements is less reliable. So the problem we face as scientists is, how are we to convey, especially to innumerate society, the many facts, theories, and predictions of science, having passed through the strong filters of the scientific method, are highly reliable, while at the same time retaining the uncertainty and the tentativeness which is characteristic of the scientific method. To put it more bluntly, the challenge that we face in the modern world, and increasingly so, is how can we compete with liars? This really requires careful thought. Liars don't follow the rules that we have imposed correctly on ourselves in developing the scientific method. So we're in sort of a fight between, it's like a fight between an Olympic wrestler who has to fight with certain rules. You're not allowed to kick your opponent. And your opponent not only doesn't obey those rules, he has a gun as well. Well, I'm an optimist. Without optimism, by the way, the ICTS, the optimism, my optimism, Spenta's optimism, the optimism of many Indian colleagues would never have come to pass. The difficulties in constructing this place were immense. It now seems obvious thing to do, but it required enormous optimism. So as an optimist, I do believe that science will triumph. It survived Pope Urban VIII's attack on Galileo. And science survived Stalin's attack on Darwinism. And it survived Hitler's attack on Jewish physics and Einstein. And science will survive Donald J. Trump and his ilk. Truth will triumph. And the ICTP, a center of science, will triumph. Thank you.
For a fantastic talk. I mean, just the right beginning for this meeting. So, David will take a few questions. Yes?
In your slide before the triumph part, you kind of cast it as a sort of monolith of science on the one hand and the liars on the other. But there have been a lot of arguments that science as it's practiced today, or for the science as it has been practiced today or over the recent past, has given short shrift to reproducibility, for example. And so there are examples in the climate science or pharmacology where people don't publish, they don't make their data nor their protocols open source, and so reproducibility it becomes impractical and so forth. So how, and people have argued that this is weakening the whole science practice. So I was wondering how you'd respond to that.
Well, there two responses. Number one, science, there are many sciences, areas of science. Some are older and more mature than others. Physics is perhaps the oldest and the most mature. In physics, people will spend their life testing cherished theories and assumptions with the knowledge, or they should understand, that their likelihood of finding a disagreement is very small. But it's still a wonderful tradition that we have in physics, that everything should be tested, reproduced over and over again with higher and higher precision. That is not true of the younger sciences necessarily. And you're referring to the fact that, and especially in the life sciences, people don't necessarily regard it as worthwhile to redo an experiment to test whether it was correct or not. And if they do, they don't necessarily publish the results. So negative results aren't published, and that really weakens the scientific method. There are other issues with the overlap of scientific research and commercial interests, which lead to distortions. There are all of these aspects, but even, you know, in fields that are mature like physics, people have biases and people have perhaps commercial interests, and we have and are continuing to develop methods to protect us against those misuses of science. So I think one thing that needs to be done is to educate the newer fields of science in the scientific method. This especially is true of a field that calls itself a science, namely economics, which has so much power over our daily lives and seems to show no interest at all in data that contradicts their assumptions, experimental improvement in experimental methods or data collection, or the other essentials of the scientific method. Again, we need to try to educate those newer sciences in the niceties of the scientific method. But one has to be careful in dealing with some of the criticisms that you alluded to. So in the debate over global warming, the opponents of the accepted, overwhelming acceptance that global warming is man-made and dangerous should be taken with many grains of salt, since they have enormous economic interests involved. And they seize upon exactly what I was saying, that scientific truths tend to be expressed with tentativeness and uncertainty, as should be, to criticize their findings. That is, so, you know, one has to separate those two problems, and I don't know how really to protect both the scientific method, which is uncertain and is always probabilistic and tentative, with the deniers who, for whatever reason, will say, well, if you can't say it's true with 100%, then, you know, there's that side and there's this side, and they're equally reasonable. How do we compete with that kind of liar? I don't know.
Yes, Avinash. Wait, just a minute.
While I agree with what you said in the talk, I always have feel one contradiction, Namely, if you take the Soviet contribution to theoretical physics and mathematics, that happened in the totalitarian society, it is huge. And now that Soviet Union has gone, that contribution is not there at all. Our last 20 years, you don't find equivalent contribution.
Well, when you let those brilliant prisoners out of the cage, they escape. So that was a very unusual situation. Physics and mathematics, well, physics received enormous support in the Soviet Union, as it, by the way, did in the West, because the physicists built bombs. And the Russian society had a great tradition, academic tradition, and those physicists and mathematicians who were in a cage, all right, but they were treated very well. When that system disappeared, well, first of all, they escaped for a variety of reasons. And second, they were no longer respected very much. So, and support in Russia for science is now almost non-existent. So it's obvious why it collapsed. Now I didn't say that you can't do science in prison. You can, but it's a good example. There was even good science done in Nazi Germany. But there's no question, in my opinion, that it would have flourished even more with the same amount of support given to science in an open and transparent society. And if you want to be convinced of that, all you need to do is read the stories of the brilliant physicists who were persecuted and jailed and killed by the Soviet government. Those people would have made great contributions as well.
Last question, Rukmini.
Thank you, Professor, for this wonderful talk. I just had one question. At some point, human beings, there was great need for abstraction, and hence came mathematics. So, and some people think mathematics is synonymous to truth. So, can we? I would like to know.
Well, mathematicians like to think that. They were, however, Gödel put a little hole in that theory, in that problem. So indeed, well, I regard mathematics as the highest form of language. Language itself is a tool to understand, comprehend, control the world. And, indeed, so the attempts of philosophers for a long time was to try to base their notion of truth on mathematics. And that would be a solid foundation. And that was Hilbert's program in the end, to reduce mathematics to logic. It didn't work, as we know. And, and I really tried to distinguish. Well, it didn't work because of Gödel. But I really wanted to try to distinguish logic. You're really thinking about mathematical truth as logic, to the even with the caveat that some things are undecidable. From what we usually, colloquially for sure, regard as truth. So mathematical propositions, theorems, things that can be proven from some set of axioms, that's fine. But there are many other truths in the world. And I regard that definition of truth as sort of the base level. So you start from there. That if you make any statement about the real world, you had better, from the beginning, be consistent and logical. And it is possible, without experiment or observation, to negate, to rule out, throw away a scientific theory just because it's inconsistent. We don't accept that. We don't accept a theory which is based on mathematics that is wrong, that is false, provably so. So that's the basic starting point. And to a large extent, in my attempts to understand what philosophers have to say about that, that's how they think about truth. But that's not really what we mean when we talk about, and certainly in science, about truth and facts and reality, and especially, in a way that impacts society's decisions. Society is not faced with the problem of, what are the public policies that emerge from the fact that 2 + 2 = 4. That doesn't affect society. So I regard mathematics sort of as a tool, like as languages that we've developed. And we have to be sure that it is consistent and logical, but it's not what reveals the truths about, well, we could discuss this more. I regard those kinds of truths as basic truths about the real world. I think mathematics is about the real world. But I'm talking about the truths that science reveals and should be guiding public policy.
Okay. Thank you, David.